Installing 33 powerful engines under one rocket and yet expect it to fly to space may sound like SpaceX is daydreaming about the impossible, but this ambiguous process that sounds too good to be true is what the company plans to achieve with Booster 7 coupled with the fully stacked Starship. But is that working out easily for the company? Capital no. Stacking 33 Raptors with 2 engines under one giant vessel has been a hell of a problem for SpaceX. But again, the company plans to work with 2 inevitable strategies, which are powerful and reusability. Stick around to the end as we discuss these concepts in detail. First things first, talking about power here, SpaceX wants to transport 100 people in a fully stacked Starship that weighs over 100 tons without a crew or propellant. Yet even when the ship is loaded with 100 passengers, payload, and 2 different types of fuel, with all these loads, the Starship will still fight to win the gravitational force, which is equal to its weight to get to orbit, and that is why SpaceX is trying hard to make use of 33 powerful engines to win all the battles that have to do with its weight and gravitational force. Now, coming to reusability, SpaceX doesn't want to spend so much money on replacing all 33 Raptor engines after every flight. Instead, they want to continue using the same engines over and over again, almost immediately after each flight. This has not yet been possible with a Starship, though SpaceX successfully practiced reusability with the Falcon 9 rocket, and the reusability process was only possible after 7 days, which is slower than expected. Let us talk more about how SpaceX was able to adopt reusability work with a Falcon 9 rocket. How does Falcon 9 get back to Earth and land successfully after a successful launch? The booster is programmed to follow a precise flight path back to Earth, and it must do a series of controlled maneuvers to stay on that path and land vertically on the landing pad. There are 3 flight controls: coal gas thrusters, grid fins, and engines that can be turned back on. The Falcon 9 has 8 nitrogen cold gas thrusters mounted near the top of the first stage. On each side of the rocket, there is a vessel with 4 thrusters in it. The coal gas thrusters are used to control the orientation of the missile. They use this expansion of pressurized gas to create thrust, which contains the orientation of the rocket. They are helpful for the flip maneuver after stage separation. Now for the next. The grid fins that can be used at the top of the first stage booster are 4 titanium grid fins. These fins are aerodynamic control surfaces that control the rocket's position and orientation before it lands. The Falcon 9 has a global positioning system and an inertial navigation system. The inertial navigation system uses several types of sensors to figure out where the booster is, how it is oriented, and how fast it is moving. The global positioning system also measures geolocation. In real time, the onboard computer gets data from the inertial navigation system and the global positioning system and compares it to the pre-programmed flight path. If the computer finds any deviations from the flight path, it tells the rocket to change its orientation and speed to land vertically. How can the same idea be used for the Starship with 33 Raptors and 2 engines? And remember that the Starship isn't landing on its legs, but on a Mechazilla catcher, so this is a problem that SpaceX has to fix. On the other hand, it's rare for a single engine that can't be used again to have several dozen test firings. So, what are the most difficult challenges of making a Raptor engine that lasts a long time and is easy to use over that long time? Anything that has to work over and over in harsh conditions is more complex than something that only works for a few minutes relative to how long a booster engine can run. The turbopumps are the most important and troublesome part. Most rocket engines have an open cycle where fuel and oxidizer are bled off the main system to drive a pair of centrifugal pumps with a turbine. The exhaust from this process is expended outside the engine belt and can be seen as a trail of black smoke because engines are usually made to be very fuel-rich. Even though having a lot of fuel helps lowering the temperature, the turbine blades and seals are still exposed to high temperatures and stress, which can damage small parts quickly. If the engine has a fully closed cycle, all fuel and oxygen are sent to the main combustion chamber, and nothing is wasted. That means one of your turbopump turbines has to run on a lean mixture, which greatly raises the combustion temperature. Until recently, Americans thought this was impossible, even though the Russians had been perfecting materials that could stand up to the heat for years. In either case, the bearing shaft and seal in those RD engines must withstand extreme conditions over and over again. Another thing to think about is the need for rocket engines that can be used more than once to start up again. This is more complicated, which means more things could go wrong. Again, the more heat expansion and contraction cycles the Bell has to go through, the more material and design work needs to be done. We're talking about a machine that has to work at the absolute limit of the materials used, with the least amount of weight, and still work after a flight that might require several start-stop cycles. Then another important thing is how hard it is to get the engine back to Earth in any usable shape. SpaceX plans to catch a Starship with Mechazilla towers, but as has been said many times, this is even crazier stuff than what has been going on during the Space Shuttle era. The key is to connect engine instrumentation and flight data to the mechanisms that cause failures and poor performance. Once the data is ready and the acceptable control limits for safe reuse are set, the engine can be used right away or quickly fixed. SpaceX hasn't said anything about whether or not the Raptor 2 engine tested at McGregor could be used again, but let's hope for the most positive news, which favor reusability. We only know that SpaceX has made 200 Raptor 2 engines so far, and that 33 have been tested on the ground and chosen to be put on booster B7. Let's say that these 33 engines are the best ones that have been tried so far. It's best to use the same engine once a day. Rocket engines need to be fixed up every time they are used. SpaceX must have a huge business for making and fixing rocket engines if it wants to launch many rockets every day. Used machines must be easy to take out and put back in. You can only use the same rocket engine many times in one day if you run into problems. The engine builder also made a lot of money from a full rebuild after every flight. NASA and the US military have used the same cost-plus system for 50 years to pay contractors. There is nothing simple or cheap about the Starship or rocket science. Only a truck can be used more than once, which only happens sometimes. If this old cast iron stoves use it once and throw it away philosophy holds, then use the new booster to send the people into orbit, and the same booster an hour later to send the refueling tank or the colony supplies into orbit. Again, let's have faith in SpaceX and applaud its success. At the same time, we are curious to wonder if they may have pushed the materials to build the hardware beyond their metallurgy limit. The humans may be years away from having the ability to create the materials to do the work. As systems get bigger and SpaceX starts to grow, their problems stop being mathematical and geometric. Falcon 9 is a great ship, but Elon's dream may not be possible with a Starship because it is too complicated. He might need to work ahead of the curve, especially if he's wasting his money, time, and reputation on failing products like Twitter. SpaceX is only working on making rocket engines that can be used once. Instead, they are sharpening their knives to make sure that the Starship launches successfully and gets into space, with a booster working on the 33 Raptor engine. Of course, they haven't tested all 33 engines yet. They have to do it batch by batch, because all the Raptor 2 engines cannot run at a time right now. SpaceX is still at the testing phase of the Starship project. The company has already proven they know what they are doing. With several trials and errors, SpaceX has gained much experience. Can the Starship achieve reusability according to SpaceX's goal, in your opinion? Please note that SpaceX Starship 120M rocket is finally full stack, and they've tested its 33 engines for launch. Just click on the video to take a deeper look into this.